So we were here yesterday. Don't think I did any examples of any naming organic compounds. So that's our next thing, is just to remind you, we want to try to minimize the numbering for the locations and functional groups. I'll talk more specifically about double and triple bonds here after we do this next set of examples. Let's do this one together, and then there will be two other examples on this thing that are covered up right now. But as we go on, I'll leave more and more for you to do. When we have an organic compound that we want to try to name, remember the first thing, don't do anything else until you identify the parent chain. And it looks like this is pretty easy to find. Parent chain is the longest continuous chain of carbons, and that's those. There is a chlorine that's attached as a branch on this thing. The chlorine would be considered a functional group, which is kind of strange to me. I think even after having taught this a lot and learned it before, a group to me is something that's plural, like there's more than one, a group. But there's just one chlorine and it's still called a functional group. I don't know. Now, when it's a functional group, it's called a chloro group. O-L-O at the end of it. It's okay. Thank you. Is this when you want?
Whenever.
Okay.
Yeah, just scheduling stuff.
Okay, all right, thanks. Yep. All right. So, how many carbons do we have? 8. So the parent is an octane. And, well, I'll write that in last. That's going to be the end of the name of it. I consider the anchor of the name of this thing always comes at the end. So, identify our functional group. It's going to be a chlorooctane. And 1, 2, 3, 4. If we start counting over here on this carbon, then that would be 4 chlorooctane. If I start counting over here, 1, 2, 3, 4, 5, that would make it 5 chlorooctane. Minimize the numbering. We're starting over here. Yes? So, the chlorine is on carbon number 4 in the parent, so we call it 4-chlorooctane. It is correct to put these together, that chloro and octane together. If I wasn't a chemistry person, I would read that and say 4-chlorooctane. But no, we would say 4-chlorooctane. That's how we do that. You okay with that? All right. Now, I'll give you this one. If you need a moment to write it out, go ahead. I'll be quiet. See if you can write this thing out and process a little bit. Grapple with it, and then we'll talk. Yeah, that would be fun too. Yeah. Yeah, like if you would leave at the end of this hour and go into the next hour. What do you think of for the parent on this one?
Yeah,
47.
Yeah, I know some of us are tempted to say heptane. But it's not. Remember, the parent is the longest continuous chain of carbons. And how do we come up with octane? Look at this. We have this chain of carbons, pretty obvious. But then, from here, we can go down here. See that? There's our longest chain of carbons. 1, 2, 3, 4, 5, 6. That would just make heptane, but then that was 6, 7, 8. It's an octane is the longest chain. And when we recognize the parent, then we see, okay, I have a functional group here, a methyl group there, and a methyl group off of here. And that's fine. The parent does not necessarily have to be a nice straight line from left to right. Sometimes it is, but not always. So our parent is octane, and now we have some methyl groups to identify. And if I could just take it back to the previous slide, this is going to use this last bullet point. Use ditride, etc. for when you have multiple identical functional groups. So we've got 3 identical functional groups. They're all methyl groups. We just have to name where they are. And if I started with this carbon on the left as carbon number 1, they're going to be high numbers. I think we're going to start with this carbon over here to number the where the functional groups are. So this is carbon number 1, 2, and 3. So there's a methyl group on carbon number 3 on the parent, methyl group on carbon number 4, and a methyl group on carbon number 5. So the way that we would name this thing is 3, 4, 5. So you're going to put 3, 4, 5, and they're all methyl groups. So it's trimethyl. Octane. That'd be the name of that thing. Yes, sir.
If you count from the left, the CH3 on the bottom, would that be 14?
1, 2, 3. Yeah, that would be 4. But if you started on the left, it would be 4, 5, 6
Oh.
trimethyloctane. Right? Yeah, you would have a 4, but the others would be minimized. Anything else about this one? Okay. Well, would you try one? This one's not bad. It's fine. Got this one? Anybody want to volunteer what they have? Go ahead, David. You have a parent of heptane, 7 carbons, and you identified this carbon as carbon number 1 to minimize the numbering where the functional group is. Perfect. So yeah, bromine is on the 2nd carbon from the end. 2-bromo would be the name of that functional group and its location. Heptane. We good with that slide? Yes, sir.
Except for chlorine and bromine, what else is there for the
You can have iodine on there. You would, if that was iodine, we'd say 2-iodoheptane. And there's several other functional groups. You can have an OH. It's called a hydroxyl. NH2 would be an amine group. So there's a few. NO2 would be a nitro group. These are the common ones, though. Chlorine, bromine, and methyl groups. That's what you're going to see more than any other. Okay. So I had mentioned that we'll talk more about unsaturated, or when you have a double or a triple bond, and this is it. Unsaturated means that you could take an unsaturated compound, react something with it, and add more atoms. It's got more room for more atoms in the compound. Because it's got a double bond. That double bond could break, and you could have a single bond with more atoms on it. So when we have a double bond, those compounds are called alkenes. And notice the formula on the alkenes, CnH2n. Remember, for the alkanes, it was H2n plus 2, and that would be saturated. That's as many H's as you can get on a compound. But alkenes have that double bond, so they lose some of their hydrogens in order to make the double bond. Yes, sir.
Can there be something like a heptyl group? Like,
You could, yeah. You'd need a long, long parent for that not to be part of the parent chain. But it's possible. Yep. Here's an example of an alkene. This would be a 7-membered chain. One of them, though, one of the bonds between carbons is a double bond, so that would be heptene, not heptane, heptene. Not only would we call it heptene, though, we also need to specify where the double bond is. So the double bond here is between numbers 3 and 4. We're trying to minimize the numbering, so we always would use the lower number, whichever carbon has got the double bond on. So 3-heptene is the name of it. Then we have the alkynes. Alkynes have a triple bond somewhere in the compound, and alkynes are really the same thing as alkenes. Just make sure you end it with YNE. And again, specify where the triple bond is. Yes?
So alkynes have the same formula as alkenes?
No, they're not the same formula. Because this would be 2 less hydrogens than an alkene would. So this would actually, the alkyne would have a formula CnH2n minus 2. Okay,